Hey guys, Fabrizio here. Today's video I wanted to show you a nice little trick to generate bolts from a geometry. So this is going to use the great combo Vex plus the solver swap. So let's get started. Alright, so here we are in Houdini. Let's start by giving proper credit to the author of this nice robot arm model. So I have downloaded this from free3d.com and this is submitted by 3D Haupt. So thanks for making that available. So back to Houdini, let's start real quick by analyzing. So here I have a subnet where I have imported this model. It has a about 1 meter in size, just so that you know the scale. So the goal of this tutorial is to create some lines that we are going to carve. So that's like the guts of it. So it's just a few lines that we're going to carve. Now we're going to carve them in a very smart way, and for that we're going to create some attributes in a solver. So we need a simulation for that. Okay. So the first step is going to be creating the lines. So the way, multiple ways to do that. The way I will do is first by creating the side effect labs voxel mesh node. So let's create a voxel mesh, and that that is just for getting ourselves a single mesh, because then it's easier for us to pick some points. In this case, we have all connected geometry, so this is just going to make our lives easier. But you can generate the curves the way you like. Okay. So now with a voxel mesh, which is basically transform that into voxels and then back to geometry, we're going to select a few points that we're going to serve as start and end points for our curves. So let's do that with a group expression node. So the group expression is a very quick way for you to generate or to pick random points. And you can use this preset 30% chance. So it starts with 30, but you can change the value from 0 to 1, 0 being 0, 1 being 100%. So let's select 0.05, like 5%, and you can check on the viewport what are selected. And let's hit 2 for points, and let's change these points. And let's give it a name, so let's call that start. And sorry, I forgot to change the group type to points. And I have a typo here. There you go. So now we have start point with 5% of all the points selected. Now, just to be a bit more clean with this, because voxel mesh generates a few groups for us, and we don't need that. So let's do a group delete and delete everything we have in there before our actual groups are created. So now we have just one group start, and let's do even less, because you see we need just a few points. So let's do 1%. And there you go. Now what I want to do is to limit that selection to a start region. So let's say the start of the arm here, and the reason why is because I want that to travel, like the curves should travel from a starting range to an end region. So let's do a group node, so a simple group node, and with that I'm going to say, let's call that start limit. So a limit region, and this is also points, and let's pick an area here. So let's say, sorry, let me move the flag here, and let's pick, let's say, this region. Okay, so now we only want random points selected, but only inside that region. And to do that real simple, we have the group combine node that can do exactly that. So let's say our start group equals the start group itself, but only what's intersecting with the start limit. And now we can check the group again, and there you go, our start is just a few points on that region. Okay, and now that's our starting points. Let's do the same for the end points. We can actually just out drag everything to reuse the nodes. So let's say this one is called end, and I want the same number, but I just want to change the seed, and let's add some random number here, just something that is different. Now this should be called end limit, and let's pick probably, sorry, let's unsee this group here on the screen. So let's pick probably the hand and also some parts on the forearm, so that looks good. So let's hit enter, and now on the group combine we have to change end limit. Okay, now our end group, it looks like this, so a few points on the hand and forearm. Good, so that's the start. Now let's create some curves out of that. To do that, I'm going to use the find shortest path node. So this is going to generate lines for us. You can select the start group and end group here, so start and end, and the mode will be from each start to each end. Now, before picking that mode, be sure to have just a few points selected, because this can like become quite expensive. So in this case, it has generated 3000 curves, which I think it's too much, but we can always do a fuse right below. So if we have any like overlapping points, it's going to get rid of those. Now we have 3000. So let's do a lot less points. So in the group expression, let's do 0.001. And you can always come back later and increase the values. And probably I want to also change those seeds to get a more interesting value. And you can always add some seeds to the group here, add the number, and then start experimenting. You can click the number and roll the mouse wheel, and it's going to give you different variations. So I wanted to have some on the upper side, so I think we need to change the end limit to add a bit of the upper part here. And I think that was it. So let's see again. Okay, now I have some lines going to the top, and that looks good. So let's go with that. So those are our input curves, right? So the beauty of this system is that you can you just need to feed in any sorts of curves, and that's going to work. Okay, great. So now let's start diving into the code itself. So for that, I need the solver SOP. So we need simulations because we are accessing the previous frame, because we want to make the boats travel along the geometry or along the primitives itself. And for that, I'm going to use like a simple carve SOP. Okay, so the carve SOP with start and end values. So basically what we're doing is like this, we're like increasing those values at every frame, like randomly for a couple for different different values for different primitives. But the brain of the whole system is going to be lying inside the solver SOP. Okay, so and that's going to be made through Vex. So let's dive inside, but before going inside the solver, be sure to pin your viewport outside of the solver, otherwise Houdini won't update the viewport. The other thing I want to do is inside the geometry spreadsheet, because we're going to check our values inside here. Is also necessary for you to pin that from outside of the solver, and that's something that can bite you many times, so be sure to just pin everything outside of the solver. Okay, so let's go back inside again. Now let's create an attribute wrangle. Attribute wrangle. So we need to access the previous frame as the input, and let's call that generate both attributes, because that's what's going to do. It's generating the attributes that we are going to use later. And we also need to run over primitives. So great, let's start with the parameters. So let's start creating whatever we want to control in that system. So the first thing I want to control is the trigger chance, because like to add some bit of like randomization to that system, we need to have different like primitives triggering boats at different times. So for that, we'll have a trigger chance that goes from 0 to 1. 0 meaning don't trigger any boat at all, and 1 meaning every primitives are going to trigger at all frames. Okay, so let's create that. It's going to be a float attribute, so let's call that trigger chance, and let's create a channel for it. So trigger chance. Now let's create another one. Let's create one for the boat size. Okay, so boat size, how lengthy the boat will be. Remember, that is basically a carve, so that's going to be the difference between start and end of a carve. It will be your boat size, so let's call that also boat size. We also have the boat speed, or how fast it's going to travel along the primitive, so let's call that boat speed. Same for the channel name. And finally, we'll have a cooldown system. And that's good because let's say you have like a boat that is fired, and then it travels along your geometry and reaches the end. Now if you don't have that cooling down system, it will re-trigger every time it reaches the end point. So this one is good for you to have a few frames in between each trigger. So that's going to again add a bit more variation to our whole system. So and that's going to be an integer because it's just the number of frames. So let's call that cooldown frames, channel of type integer, and let's give it the same name as you have in there. Great, so let's create our parameters. So let's say our trigger chance is 0.2 for 20% or less, 0.1 for 10%. Our bolt size, let's say is, I don't know, 0.1 units. Our bolt speed is let's say bolt size is 0.05 units and bolt speed is 0.15 units. And cooldown frames, let's say it is 10. Okay. Good. So let's start. This kind of stuff here is good to to practice facts. Not that it's going to be anything too difficult, but it's the logic that matters here. So it's a good exercise for that. So we're going to start creating an if statement, and that if is going to be for anything that is not yet triggered. Okay. So we're going to create a new attribute on the fly here that is called triggered. And if that is 0, meaning it's not, we don't have any bolts running and you know what, let's do a single curve just for start. Let's blast everything but a single primitive. So let's primitive, and let's pick one, this one. Okay, great. And let's preset that, and let's dive inside. And we have an error here, that's because we don't finish the line here. So let's start with a single primitive, and what I want to do is if we don't have anything triggered just yet, then we'll do something else. We're going to do something else. Okay, so we are getting an error here. That's because no, actually we don't have that anymore. Okay, good. So let's say if we don't have anything triggered yet, then we need to check if we should trigger, and for that we're going to use a random function. So again, let's start giving this triggered value or attribute a value. So let's say the triggered attribute will be equals random of the primitive number, but not only that, unless we want a fixed result for every frame, but we want a moving. Let's say as the timelines goes by, we want that random value to be different, right? Because we want to check that at every frame. So we are going to add the time variable here. Get a time with a capital T, like that. So if that value, if the random function here, which returns from 0 to 1, if that is less than our threshold or trigger chance, then this is going to return a 0 or 1 result. So this is actually a thing that will return either 0 or 1. So at every time, if we have not triggered a bolt, we are going to check if it should trigger based on a random chance that we define there. Okay, good. So let's just very slowly follow the attributes here in the spreadsheet. Remember, you need to have this is very important. You need to have that pinned at outside of the server itself. Okay, otherwise the values won't update. Okay, so let's say this first bolt at the first frame, it didn't trigger, and that's because probably or I'm sure that the random function here returned a value that is larger than the trigger chance. So we can keep going, and eventually it's going to trigger. So let's say here, so at frame 7, it's having a value that is actually triggered. Okay, so that's good. Now if that is triggered, then on the next frame it's not going to fall at this if statement anymore. It's going to the else. And in the else clause, we can let's say we want to have a counter for how many frames it was in the triggered state. So what you can do is to create a new attribute called triggered frames, and let's add 1 to that. Okay, so triggered frames is plus equals 1. Okay, and anytime it's it goes on this clause, it adds 1, but if that is the first time, let's say here we zero out that value. Okay, and there you go. Let's try that again. So at frame 1 it doesn't trigger anything. 2, 3, 4, 5, 6. On the 7th frame it triggered 1, like it's in the in the trigger state. And now watch this, this is going to start a counter. So frame 8 is 1, 2, 3, 4, 5. Now we are counting how many frames we are in the trigger state. Okay, so those are the two attributes. Now what we want to do is to start using those to construct our carve attributes, because like that's what I'm going to do, is just to get and start carve and end carve attributes that we're going to drive later on the carve node outside of the subsolver. Okay, so if this is not triggered, I want to zero out all the values. So let's say the carve start is 0 and also the carve end is 0, so that will generate an empty geometry. Okay, but if we are inside our actual emission thing here, so the triggered state, then we need to update those values. So let's update them. So this is going to be plus equals because we are accessing the old values and summing to it. So the carver start will be carver start plus, and now we need to use the boat speed. Okay, boat speed. Same on both. Sorry, those are not integers; those are floats, because we have decimal values here. Same for these ones. Cool. So, but because we are starting and ending at 0. We're going to update those values, and if we update by 0.15 at the first frame, those will be both 0.15, and it's also going to generate an empty geometry, right? So what we have to do is to add to this carve end the boat size, okay, but not at every frame, just at the first emission frame, okay. And we can do that by using the triggered frames that we have defined in here. So let's say if the triggered frames equals 1, so let's say it's the first frame that is in the triggered state, then we need to add the boat size to the carve end so that we actually have an offset between the carve start and end values. So this will be plus equals the boat size. Sorry, like that. Okay. Cool. So let's check some of those attributes again. So now I have carve start, carve end, trigger, and trigger frames. So let's say our line here starts triggering at the frame 7. There you go. We have 1 here is still 0 because on the next frame it's going to act upon those values. So if we go to frame 8, now there you go. We have a trigger frames value of 1. Our carve start is increasing by this boat speed value. So the first value is 0.15. Those are the like the actual speed, but the carve end is the current speed plus this boat size, so that it has a small offset from the start. Okay, so this can generate anything on the carve itself. Okay. Cool. So now this is already working. So it's kind of simple. It looks complicated, but it's not. And you can see this value is going to like raise until we get we get past values 1, which is not possible because we cannot carve something past 1, right? So we have to do something about that. So it's still triggered. It's still counting frames. The carve start and end values are still raising, but we need to do some stuff to reset those values. And what we want to do is to actually check if the carve start value is past 1, because in this case we don't have any like valid geometry anymore. So let's do that right below here. So if carve start is less than 1, then we need to take an action, and that action will be to set trigger to false. So let's reset the state to the idle state. What else you need to do? Probably we don't need to restart, hard start and end, because those are actually zeroed out here. Or do we need to do? No, we don't. What else you need to do? The trigger frames also zeroed out here, and that's basically it, I guess. So let's see if we can make that work. So let's say it starts at frame 7, it's triggered, and there you go. Now it's raising the values here. So once carve starts past 1, so this is the threshold. Now the next frame is going to take some action. And there you go, it's all zeroed out. Triggered state set to 0 again, triggered frames zeroed out, and now it starts looking for other opportunities to fire a bolt, but it's not like on the next frame. Remember, we have a random thing going on here, so it might or might not be that we are getting like this condition is returning true. So you can see next frame, and there you go, it's all 0, next frame 0. Now we have to start to look for another frame where this condition will return true, and there you go. Now frame 25 returned 1, and then we started the whole process again. So trigger frames raise up, carve start and ends raise up. Now we reach it to the threshold point where you need to reset. Next frame, everything resetted, and there you go. So the other attribute I want to store, not that we are going to use that right away, but it's nice to have, is the number of triggers a bolt have. Like if you want to limit the maximum times a bolt can be emitted from primitive, you can do that by storing the number of triggers. And what you can do is to, every time it triggers, let's say there, so we can do, if the frame is the first frame, we can do everything that is like everything that needs to be set like just once, you can do inside this if here. So the carve end needs to be updated. We also want to create a new variable called, or we want to update a variable called let's say non-triggers. And the nice thing about Vex is that you can just, you don't need to declare variables beforehand. You can just create them on the fly, and they start with the I'm sorry, this is plus equals 1, and they start with the default values, which is 0 in this case, and it just knows that it needs to create that variable before assigning values to it. So now let's go back to frame 1, and you have none triggers now. So if we play, you can see it start. It's too fast. Let's go back to real time here. So it starts generating, and whenever it triggers, then it updates the none triggers to 1, and then it resets everything. But this still keeps 1 because we don't want to accumulate that value. And then the next time it triggers, then that's 2, and you can count how many triggers that primitive has fired. And there you go. So this is basically the next attribute, and the final ones we need to define is how we are going to tackle these cooldown frames, right? Because remember, we have so we have fired whenever we reach the end of the carve start attribute. We are going to reset everything, and now we start a new counter, which is the cooldown frames counter. Okay, so we only can fire up anything if that frame, if that number of frames is reached. So what we want to do is, whenever the carve start is more than 1, that means it's the end of the trigger state, then we start the cooldown frames counter. So we can call that cooldown frame without s. So let's say e add cooldown frame, and that is plus equals to 1. Okay, so we can start counting how many frames this is cooling down. Okay, sorry, it's not there. It's actually here, and there you go. So now we can go forward, and you see from the start it's computing a cooldown frame. And you see whenever it triggers, so it triggered, then we need to actually zero out cooldown frame. Let's set that to 0. Again, cooldown counting. When it's on, it's zeroed. Now we have 0 cooldown frames. When it reaches 1, past 1, then resets everything. Cooldown counter starts to take place. Now it's counting up again. When it eventually triggers once again, triggered. Now the next frame is going to 0 that value, and there you go. So that is the new counter for cooldown frames. And now the last thing we want to do is to actually look after these cooldown frames, cooldown frame variable, check that against our defined parameter here, and if that is true, or if the number of like the cooldown frame number is past the number of cooldown frames, only then we can actually set the state as triggered. So we have another condition here. Okay, so to do that, we can do that right after this triggered value is set, because we first check against the random function here, and if that returns true, then we go to another if. So if our cooldown frame, or actually our value here, our attribute cooldown frame, so if this is greater than the number of frames we need to wait for it to cool down, and there's another catch here, because if this is the first trigger and it's taking care of the cooldown frame, it's going to wait for that amount of frames before even triggering the first time. So we have to take the first trigger time, like the first trigger, out of the equation here, and we can do that by checking this these non-triggers we have defined. So if that is true, or if that is false, let's do the false condition. So let's invert that. If the cooldown frame is less, it's less than number of frames we have defined, and let's do another condition here, and the number of triggers is more than 0, that means the number of triggers is okay. So let me break down that for it, because it might be a bit confusing. So what I'm asking Houdini here is if the current counter for the cooldown system is less than the number of cooldown frames we needed to wait, and if the number of triggers is more than 0, that means only check for that value if we have already triggered at least once. So if that is the case, then you check your cooldown frame against the maximum number of frames we need to wait, and if that is true, that means your triggered value should always be false. Okay, so 0. So this is basically overwriting any values you have in here based on that condition. And that's basically it, I guess. So we start our cooldown frames, and it's counting. Now we have triggered, so we have 1 here, and then we have the trigger frames counter raising. Cooldown frame is zeroed. Number of triggers has increased by 1, and carve start and end values will start raising. There you go. We are close to the threshold frame to reset everything. Now you should see those values being resetted. This cooldown counter will start counting frames. These non-triggers will keep the value. Triggered will be 0, and triggered frames will be 0. And there you go. That's exactly what happened. And that's actually it. So you see, it's just a few lines of acts. It looks a bit complicated, but it's really not. It's just a bit of logic involved. And let's go back to our viewport here. And now the thing becomes as simple as applying that carve operator, but we cannot use vex attributes directly here. So we need to actually run that into a for each primitive loop. For each primitive, then we're going to use the carve, and so there you go. We're going to do the carve. So one thing here is I'm going to delete that blast so that you can have all your curves again. And one thing I'm going to do here, because this can get quite expensive because we're running inside a for loop, I want to take the chance to use the compile blocks. Okay, so the compile blocks, let's add some compile block node here. So this will greatly increase performance, and the first thing you need to do is check if your nodes inside are compilable, and you can do that by using hitting the D key for the display options, or this little eye icon, and you can go to the context specific badges and then non-compilable sub badge, and you can set that to large, for example. So any nodes that are not compilable are going to get this icon, so as you can see here, but in this case carve is actually compilable, so we are good to use that inside the compile block. Okay, so let's hide that again, and don't forget to go into your block end sub here and toggle multi-threaded when compiled. Now for this one to work, we need to get access to the attributes created in the solver, so we can do that by well, you cannot use any prim functions here because compile blocks won't allow for it. So or actually you can do, but you can access that by using any string path. You have to actually use spare inputs. So for that I'm going to create sorry, let's get that to the full value. So let's create a new spare input here, so add spare input, and that is going to be our start of the loop. So we need to access information from geometry that is coming into the loop, so that's basically it. And we can access that by using the -1 index. So let's now query the value. So it's just carve start and carve end. That's the only values we need to access. Otherwise the other ones are just for utilities for the system to run properly. So we can use the primitive function for -1, which means the geometry that is defined by this reference here. So what you want to query is for the prim number 0, which is because it's inside the loop, it's always 0, and then the attribute name is carve start. Start, and then the default value, in case it doesn't find that attribute, is always 0. Okay, so let's copy and paste to the next line. Now it's carve end, and I guess that is basically it. So let's see if that is working, and there you go. It is too fast right now. We need to properly change the parameters here. So let's do one thing to make our lives easier so that we don't need to go inside the solver every time. Let's do a edit parameter interface, and I want to create a new folder that's going to be called bolts emission, and let's dive inside the solver and let's get our attributes and our parameters and just add them here. And there you go, apply and accept. Now we can control everything from outside of the node. And let's start tweaking the values. So trigger chance 0.1 looks good. Bolt size, let's do smaller, or let's do the speed much smaller. Let's do 0.5, cooldown frames 10. That's good. So let's play and check what we get. So there you go. Now we have a lot of bolts firing at the same time. We can probably increase the bolt speed, or decrease the bolt speed and increase the bolt size. So let's say this is 0.1 and the bolt speed is 0.02, and remember those are in word units, so depends on the size of our geometry. You can always normalize those values, but this is in word units. So let's, and there you go. This is more kind of slow motion, and we can see that with the template of the arm, right? So it's super slow. Now let's start working on the time. So let's say both speed needs to be a bit faster, and because this is simulated, you have to go back to the first frame. But there you go, something like that. Looks cool. Right, let's yeah, let's go with that for the moment. Now I want that to look better. So what we can do is, and again, remember, this can work on any curves you feed in. So this is the nice thing about this setup. Anything you feed in as curves into that solver, it's going to basically work. Okay, so what I want to do is with those curves, I want to probably make them stick out of the geometry. So what you can do here is, after our fuse, remember this is our mesh. So this is our voxel mesh. We can compute normals for that voxel. So let's check if that has normals already. It doesn't. So let's create a normal node. So let's compute some normals for this voxel mesh. And what we want to do is to ray the curves onto those this voxel mesh. And what I want to do is, instead of actually transforming the points, I just want to store the normal. So let's store the vertex normal. Sorry, this is switch it. Yeah. So let's uncheck show guide geometry and let's store the vertex normal. Because now I want to push the curves like outside of the geometry, and you can just do a peak for that, not that much, just a little bit. And of course you can do all sorts of stuff here. For example, you can do a smooth if you think it's like too yeah, that looks good. And I guess on top of that I'm going to add another noise layer. So let's do let's set that to black, because I like darker backgrounds. So what I can do here is to resample the curve. So let's see how many points we have. Yeah, probably we need a lot more points. Let's resample. So let's resample with 0.001 more or less, 0.005. That looks better, or even less, 2. And now let's add a new mountain stop here. So let's add a very fine noise or very high frequency noise, so that really resembles some boats. Yeah, something like that. Cool, so that's all we need. So just need to feed that in the solver again. Oops, sorry. And there you go. Let's see what is the result of that. So you see a few boats going on. Probably we want less. Or more smooth, maybe. And yeah, something like that. I still think we can lower the trigger chains to have fewer boats, and we can increase the cooldown frames to have more spacing between each trigger. There you go, that looks better. And what you can do is also give these curves a bit of noise. That should be really cool to get them moving, right? So let's go right before solver. Let's add a attribute noise. Let's make the curves sway a little bit. So let's say this is going to change point position. The values will be add, and range will be 0 centered, amplitude is very small, and we also need to change the element size here, and this is animated. So let's say post duration is smaller. So let's play and see what you have. And that, I think that looks cool. Let's see how that looks on the boats themselves. It is very subtle, I guess, so we can try and up the post duration. Yeah, okay. Or actually, I think that needs to happen after the solve, sorry. Yeah, that needs to happen after the solve. Yeah, you see we have some this kind of internal motion to the boats, which looks really nice. So yeah, that's the how you can create the boats, and you see it's very like organic. It's very nice. You can get very like it's not something that looks like it looks very organic. And now comes the time for us to create some attributes along the boats themselves to make them look better on the screen. So let's do some things here. First, I'm going to randomize their colors a little bit so that they resemble a little bit more of that bluish kind of boat colors. So let's do that with a Rango, because I like to use ramps for that. So let's call that set color. That's going to happen at the primitive level. So let's do at CD will be vector. So we need to cast our parameter to a vector, since we need a ramp that is a color ramp and not a scalar ramp. So we can do vector, and then we need a ch ramp. Let's call that color, and then this will be a random function using the okay, you know what, because probably this thing here is going to change the primitive indices. It's a good idea for us to store those into a boat ID attribute here. So let's let's do an attribute create or an attribute Rango. Doesn't matter, it's just to store primitive IDs. So let's call that boat ID. So boat ID, that's going to be the primnum. And well, the reason for that is because let's copy that, and it runs at the primitives. So the reason for that is because using compile blocks will throw your will send your executions to all the cores. It might be that the returning values happens differently at different times, and that's going to mess with your IDs. So that's why we need to store them before that thing takes place. So now we can use them in here. So let's do a random using those IDs, and we can define our colors. So let's change our interpolation to constant, and the values here, let's pick some bluish tones. So let's say we need something like that, blue one, and maybe a couple ones are like kind of white, like so. You can see we have some colors that resemble boats. And the other thing I want to do, and let's uncheck the template geometry. So the other thing I want to do is to fade the start and end of those boats. Let's fade that out, and I want to probably resample the curves to well, we don't want to work on the curves, but just to compute the curve view attribute, which you can use in another Rango. So let's do attribute Rango. So this will be a point Rango, and probably it's a good idea for us to transform this color into a point color. So let's do an attribute promote before everything. Let's transform CD from primitive to point. Okay, so now we have in this Rango here, we're going to fade tips. So we are going to control the alpha. So alpha is a non-attribute for Houdini. You can fade points with that. So let's say 0.5. It's going to be a bit more transparent. 0.1. There you go. So you can use that to fade your points, or in this case the curves. So what we can do is use that curve view attribute to have a ramp that controls where it should fade. So we can do that using a ch ramp, and we're going to call that fade, and we are going to use the curve, or it's a float attribute, curve view, which is computed from the resample node. Okay, so if we use that, you can see right now we have a fade starting on the start, like a linear, but what we also want to do is to have something more like this, so it fades at the start and at end, and we can control, and let's also make that into monotonic cubic, so we have a nicer fall off, like nicer tails, so we can do something like that. So it starts from here to here. It's a bit more interesting that it fades. The other thing I want to do is probably to, let's see here, so this is the start. Yeah, so this part here, probably I want to have less fade going on here, because I want to give it a very like brighter color, and we can do that by doing a, let's say, fade tips and brighter start. What I want to do is to interpolate the current color with a new color that I'm going to define in here. So let's create a new color, and let's do add CD will be a lerp for linear interpolation between the current color and the, you know what, let's do that in another wrangle, sorry. Just to keep things more easy and to understand, so let's do another attribute wrangle. Let's call that brightening start, or start. Start looks good. Okay, so good. Let's create a new thing here. So CD will be lerp between the current color and the new color we're going to define. That's going to be channel of type vector. Let's call that tip color. And the interpolation will be based also on that curve, so let's copy and paste that. So this thing here, and we need to probably cast that to a float value because it doesn't know it's a float yet. And there you go, now we can apply. And the first thing I need to do is to change this tip color to a color parameter instead of vector. It's the same thing, but you need to tell Houdini you want to actually see that parameter as a color. So let's go here and change that to color, apply. And let's pick a color. So let's say I want this very like reddish tone, maybe a bit more to the orange side. And the actual fade starts happening at here maybe, and I want to be a very bright value, so let's do 3, and I think that's it. So you can see we have some like nice little sparky thing going on there. We can even switch the colors here, so there you go. Now we have something like that, which is very cool, right? So you can couple a bit of those yeah, we can couple this kind of boats thing with sparks, with some sparks to generate some dead robots thing, some like malfunctioning sci-fi stuff, and this is very cool. So let's finally merge that with the original geometry. So let's merge that with the robot arm that we have up there. Probably need to define a color here, otherwise it's going to look black. So let's do white. And there you go. So that's the end result, and I think that's a very cool effect. Of course, it really shines when rendered. So when you render that, you can really see how cool that can look. And of course, now this is just everything procedural. The beauty of Houdini is you can just go to your start group and maybe change the seed and make it compute again, and you have a different type of simulation going on. You can always go to your to your end group here and limit, and change that to have more geometry, or maybe just the upper part, which also can make something really cool like that. And let's see what that gives us. So let's go back to the end here. So see, it reaches more towards the upper part. It's a very cool effect. And well, you can always go back to one of my posts where I talk about a branching system, which I developed for doing actual trees, but they can very well be transformed into boats, like into real like lightning boats. So you can always use that, and it's called FC branches. And you just be sure to go back a few posts and look for that. You can always generate branching systems out of curves. Like that is of course too much, but you can tweak the length, you can tweak the noise amount that it's in there, and you can add a few more. Sorry, I just need to remember those settings, but we have the segment length here, which we can define as smaller. We can change the rotations, something like that. And you can do less those. And you have like some some boats that can have branches and stuff like that. So let's go a bit more. And you can try and feed that into the solver, and it can like use those rays. And I think I need to sorry, this needs to go before this thing here, right? And yeah, you see you have some other smaller sparks. Still probably we would need to fuse them so that we have the branches actually being part of the lines themselves, something like this. And now I guess we can have something good. Yeah, well, I have to do some work for it to like be like a single curve, but you get the idea. So this is a very nice, and it actually created some nice sparks that actually look good. So yeah, there you go. And anytime you want to change this, let's bypass this for a second. So you can just go ahead. Let's say you want to generate more curves, so let's increase the end amount to a bit more. Let's say 0.005, and now I have much more curves, and you see it starts becoming looking really cool. Okay, so that's how I went about creating those sort of stuff. Let's go back here real quick to the last node. So yeah, that's with that. I think it's a great place to start developing your own boats system. And I hope you like this one, and I will let the zip file for download and if you guys want to take a look at that, you can always merge this into an HDA that is ready to go. Okay, so see you in the next time. Take care and goodbye.